Hello folks, let's come back to our next video. We are now, last class we finished the exercise 6.4. We're gradually finishing all our uh, application. But that is a little bit voluminous thing. So that's how we come to the last application, that is maxima and minima. It's very important from all point of view, like from the exam point of view, or from the understanding point of view. There are many things that are dependent on this, and so on. So that's it. So that's our next application, maxima and minima. Now you could just go through the textbook, and there is a lot of written material that's there. That's worth going through. You can go through all that. It gives you a clear idea as to what is maxima minima. I'll just roughly explain what is maxima minima, and we will get started with the problem directly. Actually, the meaning of maximum minima is that whenever we plot a graph, whenever they give us a function, we generally plot the graph of a function. So sometimes it so happens, not always, but sometimes it so happens that your graph looks like this. It's not always, but does happen. If it does happen like this, then that function is said to have maxima minima, in the sense that the place where you have this peak-like thing, the mountain-like thing, this place is called as, or that point is called as point of maxima. And the place where you have this valley, that's how we call it in normal English. And that point is called as point of minima. That's how it is. Now, this is like every time you are given a function, you're not going to sit and plot and find out where there is maxima minima. It's not feasible. So in order to avoid that hassle, we come to the algebraic part, and then we do the checking algebraically, and then we decide where is the maxima minima. That's throughout that has been our approach, because geometrically it is this, but geometrically every time plotting etc. is not possible. So we go in for the algebraic tool, and we try to get whatever that they ask us. So that's how it is. So initial some problems, they will ask us where is a maxima, what is a maxima, and all that. It can be, they can ask you maxima minima point, that means x, and function, that is f of that x, that they will ask. So as per the problem that we will check out, not everywhere you'll have maxima minima, because every graph need not be like this. Some graph will go like, you can have graphs which will like will go like that. You have graphs like this, or you can have graphs which like moves like this, or there are graphs which goes anyhow. There are a lot of examples given in the textbook. So as per that, it becomes your answers will vary depending on the nature of the graph, whether maxima is existing, minima is existing, and all that. So our first two questions, basically, they are of that kind, where they ask us whether there is a maximum, minimum, and all. That's more on the understanding part, not so important from the exam point of view. I would tell you that in the exercise 6.5, the question number 1 and 2, we have not seen it occurring much in the exam, but it's good from the exam point of view. It makes the concept, now it's good from the understanding point of view. It makes your concepts clear. So that's how the question 1 and 2. So that we will go. We will just try to go gradually and try to understand. Then as the exercise proceeds, we take up the algebraic tool, and then we try to find out the points of maxima, minima, and so on. There are two ways, the first derivative test and the second derivative test. The first method, it is little clumsy and long, so we don't generally go for that method. We take the second derivative test, that's called as the second method, and that's what we generally will take and will do. So right away I think we can start by just talking generally. It will not be clear to you, so we'll go for the example actually, and that's how you'll realize how it can be done. What is it? Exercise 6.5, the question number 1, find the maximum and minimum values. You can see the question, maximum and minimum values means F they are asking. Maxima and minimum point, sometimes they will ask, that is X. So that way, maximum, find the maximum and minimum values, if any, for the following functions which is given by. So they will give us the functions, they ask us the function's value, where it is maximum and minimum. So let's take the first question, first subpart, 2x minus 1 the whole squared plus 3. I'm a little bad at taking from there and copying, generally I make a mistake. So I have to cross check many times. I think one by one we will take, because There is a bit of understanding. No? We'll not hurry up with the concepts. F of x is 2x minus 1 the whole square plus 3. Yeah. For a person who knows it, it's very easy. But because we are beginners, we should understand this properly. It says that y equal to, it's something like, see, I told you linear. Linear in algebra, they behave almost like x. How x will behave, that way only it will behave. So you can think of this graph like this. Y equal to x squared plus 3. Had the graph been like this, how would it have looked? Okay. Again, now that is difficult. So let's go for y equal to x squared. We know, yeah, y equal to x squared, we know the graph. It is the parabola, no, which we learnt last year, x squared equal to y. Is going to be a parabola like this, x squared plus y. Now this plus 3 means this parabola won't pass through the origin, it is little up by 3 units, that's the meaning. So it's like this, it's like if there is 3 here, then your parabola would be like this. So that's the meaning. Since it's not x there, it's 2x minus 1. There is no possibility that is symmetric about the y-axis is not possible. It will be little on that side. Now we have our AI tools. You have the Google Bard and you have the Chat GPT and all that. You can just input this question and they readily give you the graph, how the graph is. So probably you can obtain the graph like that. Otherwise, you can actually, if you want to actually know how the graph is, you can take some set of points and just plot it, and you will be able to see how the graph goes. Roughly, the graph is going to be it's, as I told you, it's not symmetric about. It will not be symmetric about the y-axis, so it will be something of this type. From here, from 3. No, it will be like that. So x-axis, y-axis, we all know, something like that. So the graph could be like this. So you can understand when you look at the graph, where the function, this graph is a function. Huh? So where does it take a rock bottom value? The minimum value that it will take is at 3. When it reaches minimum, then it starts increasing. Huh? So the minimum value is at 3 and maximum we cannot tell. Why? Because as you keep on plotting values of x, this will keep on going. It will keep on, it moves. So from the graph, it's very clear to us that the minimum value of the function is 3 and there is no maximum value. That's clear to us. So, but as I told you, every time that kind of plotting doesn't work well. So that is why we can take the algebraic tool. And what algebraic tool we are going to take over here is, we are observing that 2x minus 1 the whole squared is there. Now you know that anything that is whole squared is always positive. So let's catch hold of that fact. So let's write, we know that, what do we know? We know that 2x minus 1 the whole squared has to be positive. Yeah, why? Because it's a square. So square is always positive. So because the square is positive, so what you're going to do, you're going to add this 3 to both sides because you want to reach to the function. So let's add 3 to both sides. When we add 3 to both sides, this becomes the function. It's your function and looks as though the function is greater than or equal to 3. So that's it. That's how we say. So therefore, the minimum value is 3 and maximum value as such does not exist. Does not exist. Why? Because like you cannot say, there's maximum means what? There is no value after that. You cannot tell that. As you keep on changing the values of x, you can get more and more higher values. You cannot tell that. So that's it. So maybe we can get ourselves accustomed with this. And if you want, we can take the second problem also. Let's see if it's as good or whether it is going to be even worse. Let's check. They say that there is fx is 9x squared plus 12x plus 2. Oh, that's a little different strategy. F of x is 9x squared plus 12x plus 2. See, as such, we'll try to, in these kind of problems, we'll try to get a whole squared if possible. Then only our arguments, we can present our arguments properly. So what we are going to do over here is we are going to use the logic of completing squares, and that's how we are going to get the f of x changed. Now it's very clear to us that 9x squared plus 12x, we can always write it as 9x squared plus 12x plus something, so that this is a whole square, something of the type a plus b the whole square. That's what we are aiming at. And that can be easily done. How you can do it is, this 9x squared can be written as 3x the whole square. 12x, we could write it as 2 into 3x. 2, because always we have no a plus b the whole square always has that 2, a squared plus 2ab plus b squared, like that. So a squared plus 2ab. So generally we segregate, and this 3x, because 3x is here, we are segregating it like that. Now we have the middle term as 12x, and we have already obtained 6x. So we require another 2 to make it 12. So that is what b's value is. We understand that. So that's how we find out the b value. Our work is to get the b value. So what we have done is, we have tried to write the expression in the type a squared plus 2ab. When we try to write it like that, we are able to catch hold of that value of b. Once you get the value of b, it's easy to complete square, because you're going to add and subtract b squared. B for us is 2, so b squared is 4. Now you cannot suddenly add a 4 to an expression. It will spoil the balance of that expression. So you are allowed to add and subtract, because when you add and subtract, you don't change the value at all. So since we need to introduce 4, we add 4, but at the same time we subtract 4 from here, so that net effect, we are not disturbing the value, but at the same time we are achieving what we require. So that this is the important part of the whole thing, deciding the value of b. Once you are able to decide the value of b, you've won the battle. That's it. That's it. The whole problem is based on that. So now we have, this expression can be written as 3x plus 2 the whole square, and this is minus 2. Or if you want to understand it better, it is 3x plus 2 the whole square plus minus 2. Now, I will also give you the geometric interpretation, but we'll basically be working algebraically. So as I told you, we can look at it as y equal to 3x plus 2 the whole square plus minus 2. So again, we will try to linears, as I told you, always work like x. So we kind of neglect this and let it look like x squared plus minus 2. Okay, then that minus 2 is also disturbing for us. So let's write y equal to x squared, which we all know that the graph is going to be like this. That is x squared equal to y. Now, because there is a plus minus 2, means your origin is shifted to minus 2. That means you are going to move, that plus thing means that's the place where your origin is. So it's no longer in the origin. Your origin is getting shifted to minus 2, and your parabola starts from here, that way. So that's going to be your parabola. Also, now because it's 3x plus 2 businesses coming, it's all the time possible that it will not be, the y-axis will not be the symmetric axis. It will shift either that side or this side. Parabola could shift anywhere. So then in that case, the resultant parabola would be, see, the parabola that I am plotting, it's just a general parabola. I have not taken the points and plotted. If you want correct parabola, you have to take the points plotted to get the correct parabola. This is just for the explanation that I am trying to plot the parabola. We have not plotted the points and then we have not taken the points, plotted it. It's just the general explanation that we are giving. In the exam, we are going to do only the algebraic part. Geometric part is for understanding, and in that case, we'll take the points properly and then we'll plot it and we'll understand that this is the parabola. But roughly, it will look like this. Okay. So as I told you, so your parabola could be, something like this. Minus 2. Let me reserve the place for minus 2. Suppose say minus 2 is here. Then your parabola, because it is at 3x plus 2. I'm not very sure it can be on this side or it can be on this side. It depends on how the thing will be. Parabola could be something like this. It could be something like this. So this is going to be a parabola. Now from this parabola, it's very clear to us that there is a minimum value at minus 2, but there is no maximum value. Isn't it clear? That's quite clear from this figure. But then we will also do it algebraically and see how it comes algebraically. Let's check. So it's like before. We'll take the square. We know that. Yeah, what do we know? We know that 3x plus 2 the whole squared is greater than or equal to 0. So because it's greater than or equal to 0, so in order to reach the function, we are subtracting 2 on both sides. So what are we getting? Here we get the function is greater than or equal to minus 2, something like this. Same way. So that makes it very clear that there is a minimum value. Minimum value is minus 2 and maximum value does not exist because it moves no on the top side like that. That's how it is. So that's our problem 1 and 2. No, not the problem 1 and 2, sub questions 1 and 2. Sub questions 3 and 4 probably will meet in the next video. Thank you.